Hello, Algebra 2 peeps. We are going to do a little factoring review from Algebra 1 before we move into this next chapter. So these notes are going to walk you through some of the steps that you should look for when you're doing factoring. So this first section is about the greatest common factor. So you're looking for a number or a variable that is common to every term. So in this first example, we have 3x squared plus 12x. So I notice that 3 goes into both 12 and 3, and each term has an x. So I pull the 3x out in front, and what that means, so I had this originally, to figure out what goes in the parentheses after you pull out that initial 3x, it's like you're dividing each term by 3x. So that first term, all I have left is x. The second term, 3 goes into 12 4 times, and the x's cancel. So that gives me 3x plus 4. All right, so what I'm going to ask you guys to do is try and pull out what you find common to that. And you might want to pause the video and come back before you look at the answer. All right, so I will just give you a cue to pause, try it, and then I'm going to fill this in. So you should find okay, so hopefully you unpaused and didn't just copy it down, but that's up to you whether you want the practice. So notice each term here really only has a factor of 4 common to everything, and then that comes out. All right, so that's important because you always want to look for your GCF before you start any problem. Now, this next section gets back into factoring. Now we're going to start off when we have a is 1. These are the easier ones that you did in Algebra 1. And I'm going to use sort of the little shortcut that says this little diamond, but that's as far as we're going to go. So we have x squared plus 6x plus 8. And we want to factor it into 2 parentheses. So it's kind of like unfoiling. So the way that we do this is we take a times c, which in this case is 1 times 8, and we put that on top. And the middle term, which is your b, goes on the bottom. And we want to ask ourselves, what times what is 8, but adds up to 6? Because when you FOIL, remember that foiling, first, outer, inner, last. So the first terms have to give us x squared. So we know that's got to be x. The last term has to give us 8. So what times what is 8? So we look at factors of 8. You have 8 and 1, 2 and 4, and we notice that 2 and 4 would add up to 6. So this will be a positive 2 and a positive 4. Now, if you have negatives, it still works. So we're going to do this next one. So a, again, is 1. 1 times a negative 45, that goes on top. The middle term goes on the bottom. And we want to ask ourselves, what times what is a negative 45 but adds up to a negative 12? So we look at some factors. We know 5 times 9 is 45. I know 15 times 3 because I can pull out a 3 here and rearrange my factors. And if I had a negative 15 plus 3, that would give me what I'm looking for. So this will be a negative 15, this will be 3, and that tells me, so this will be x and x to get my first term, negative 15 and a positive 3. All right, again, go ahead and pause the video and try this next one, and then we'll see if you get the same thing I got. So hopefully if you're back, you paused it and you tried so that you got x minus 2, because this one you would have 18 on top, negative 11. The only way you can get a positive product and a negative sum is if both of your terms are negative, since a negative times a negative is a positive. Okay? Now that was primarily how you did it in Algebra 1. And I do know this is actually the same worksheet we did in geometry, so we had this review before. Now we're going to go on to factoring when it's a little more difficult, which is what we emphasize in Algebra 2. So notice here, your A value will not be 1. So this makes it a little more difficult. Those side numbers are not what's going to go in your parentheses. So the first way I'm going to show you is called factor by grouping. So we start off the same way. I'm going to start off with A times C, which is in this case now 4 times a negative 12. My middle term is a negative 13. And I still want to figure out what times what is 48, or negative 48, but adds up to a negative 13. So 48 is 12 and 4. That won't get me to 13. So if I look at kind of rearrange things, hopefully you'll come up with 16 and 3. A negative 16 plus 3 would give me a negative 13. Now those do not go in the parentheses. So what we're going to do is we rewrite that middle term, because we deliberately made it so that that equals a negative 13. I rewrite this as 4x squared minus 16x plus 3x minus 12. And what we're going to do is called factor by grouping. I'm going to group these two terms and these two terms and factor out what's common. So out of the 4x squared minus 16x, I notice they each have a factor of 4 and they each have an x, so that would leave me with x minus 4. In the next term, I notice that each has a factor of 3, and I can then factor out and I get x minus 4. You should always, 100% of the time, notice that you have this common factor that I can factor out again. So this becomes x minus 4. I'm pulling it out of each term. And what am I left with is sitting out in front of the parentheses, 4x plus 3. And that's how that would factor using factor by grouping. All right. So I'm going to walk through this next one, but if you want to pause the video so that you can do it on your own, go ahead and then you can check. So we always start off the same. A times C, which is 36. 13 goes down here. 9 and 4 will add up to 13, but multiply to 36. So I rewrite my middle term as 9x plus 4x, because that adds up to 13, plus 6. And then we do our factor by grouping. So what I'm going to end up with here is I have a common factor of 3. So I'll have 3x, sorry. So I will have a 2x plus 3. And on this other one I have a common factor of just 2, but notice that leaves me with 2x plus 3. Again, always, you did it right if you see these are both the same. So I pull out that common factor of 2x plus 3, and what remains in front of the parentheses is my other factor. And these always have a built-in check because you can always FOIL it back through and see if you get back what you started with. Okay, factor by grouping, always, 100% of the time, if it's factorable, is a nice process. It's a lot of work though. So I have a little shortcut which kind of depends on if you are good at pattern recognition and you understand FOIL. So if you don't like this method, that's totally okay. I just like to present you with another option. So we're going to do exactly the same example, but a different way. We start off the same way. So we did this problem above. So we have a negative 48 here. We know this is a negative 13. And so we already came up with this would be negative 16 and a positive 3. All right, so I'm going to go and start my parentheses. So I notice that my first term goes into negative 16. So I'm going to write this as 4x and x, because my first term has to give me that product. Remember FOIL, the first term, the product of the first terms has to give you that 4x squared. Now here's where the little double rainbow comes in. When you do FOIL, the outer and the inner, so this is your outer and your inner product, is what combines to give you the middle term. So these side numbers, they're what goes on your double rainbow. So this, I'm going to put the negative 16 here because I know that 4 goes into it, and the 3 will go here because this is just like a 1. And you're going to ask yourself, 4x times what is going to equal negative 16? And so that answer, or actually let's just focus on the 4. 4 times what is a negative 16? That's going to be minus 4. And since this is a 1, it's like saying 1 times what equals 3. That's going to be a positive 3. And notice we got exactly the same answer as we had up above. The x minus 4, 4x plus 3. So you're kind of utilizing these numbers go on the rainbow based on what goes into one of the factors. All right, if that doesn't make sense, by all means do the factor by grouping because that always works. But I will do one more example down here of one we haven't done so you can see how this would work again. So if you want to pause and try it on your own, go ahead. Otherwise, I'll just keep going through this example. So what goes on top is a times c, on bottom negative 17. So what times what is 16 but adds up to a negative 17? Well, they both have to be negative to get a positive product and a negative sum. So now I set up my rainbow, or I start to do my parentheses. Now I know it's going to be 4x and x because I know that 4 goes into a negative 16. So I'm already kind of thinking ahead. So this will be my negative 16, this will be my negative 1. What goes in the parentheses will be 4 times what is negative 16, and 1 times what is a negative 1. That will be your negative 1. And there you have it factored. Now when you're factoring, it's also helpful if you can notice some patterns. There are some shortcuts that happen. So in Algebra 1 you learned about something called a difference of squares. And that was, you learned it from if you had a plus b, a minus b, and you FOIL that, you would be adding and subtracting the middle term so that you have no middle term. You only have the two terms. Well, knowing that, going backwards, it's helpful to be able to factor something because you realize that if I gave you 4x squared minus 9, that's the result of take the square root of the first term, which would be 2x, so these 2x's would go here, square root of the last term, which would be 3, and then you throw in a plus and a minus because it has no middle term. This only works when you have the negative here because we have a difference. That's what that difference means. You have subtraction there of two perfect squares. So again, if you want to pause before trying this one, but I'll go ahead and go into it. So we don't have to do the whole diamond and figure out things because I know I'm just going to take the square root of 25x squared. That'll be my first terms in both of them. And then I take the square root of 49y squared, which is 7y. And then I throw in a plus or a minus, which is what made the middle term go away. So if you notice the perfect square, it's really nice. You can still use the other strategy. You'll just find then you don't have a middle term. Now perfect squares is another one. It's nice. Perfect square means you have this. Please realize you may not distribute that squared through. You still have to do a plus b times a plus b. But since you're doing the same thing times itself, this middle term will always be 2 times the product of a and b. I myself don't always recognize a perfect square right off the bat, but if you do, it's kind of nice. So things I would look for is, do I have a perfect square in the first term, a perfect square in the middle term, and then I would just check. So notice that if I took the square root of the first term, that would be 2x. Square root of the last term would be 9. 2 times 9 is 18, so if I double that, I did get 36. So that's kind of, you can, if you notice, you can try the shortcut. So for instance, again, if you want to pause and try this example. So square root of 9x squared, that's going to give me 3x. Square root of 25 gives me 5. This negative tells me to make that a negative, and then I check. Negative 15 times 2 is in fact negative 30, so that's how that would factor. All right, so below are some examples for you to try, and just a little reminder, do not forget you have to set the equation equal to 0 before you even start, and always look for a common factor to pull out first. Now on these, you're actually going to solve, so that means you have to set each factor equal to 0 and actually find the value of x. All right, that's your homework.